Why do software guardrails fundamentally fail as a security boundary for agents?
We put them into these jails and we watch them try to get out and try to get secrets. You can block commands and they will wrap those commands like a Python interpreter or a shell script, or they'll create symlinks, and they would just keep going and going and going and going and going until they achieve that goal. It's that same thing of the same mistakes happening again. We're going to retrofit, we're going to try to catch up, and we'll never really quite catch up. Everything seems to come down to eventually put in an LLM as a judge. You can't rely on these things. You cannot have a mess up on that level. We got volumes and volumes of software like we never had before. These things do go off the rails. Who's going to get them back on course?
What does this tell us about the viability of human in the loop when it comes to being a security control for AI agents at scale?
Gosh, it's concerning. It really is. Okay.
Thank you for joining the Resilient Cyber Show. My name is Chris Hughes, and today I'm joined by Luke Hines. Luke, thanks for being here, Luke.
Thank you for having me, Chris. It's great to catch up again, yeah.
Yeah, it feels like it's been several years, honestly, since you came on the show. Last time we talked quite a bit about software supply chain, if I'm not mistaken, which I know we'll touch on today. Yeah. But man, a lot has changed in the last couple of years. You're putting it lightly, we're so much going on. But for folks that don't know you, don't know what you've done in your career or what you're up to nowadays, can you give people a quick of a catch up?
Absolutely. So I've always been a software engineer. I say that I've dabbled in other areas, sort of consulting, a little bit of technical pre-sales, but I've always returned to engineering for a long old time. I won't say how long. Well, I'm not so guarded about my age, but it's a good 20 years. Okay. And, I'm in this game because I love it still. I really do. I really love all of this. I always joke that I could be collecting, the shopping mart, the local shopping mart, the trolleys. You get the guy that collect them. I would do that and then write code in the evening. I don't know that my wife would like that so much, but I do. This is a passion for me, so I'm really lucky there. Yeah, and I'm a software engineer, and I've predominantly been around security, but more the sort of building of security-centric platforms and tools, and more than sort of red teaming and the other sort of areas. Because people talk about cybersecurity, but it's so wide, isn't it? There's so many facets. It's like networking. Networking is not just a singular thing. There's so much involved, So yeah, a software engineer for quite a while. Open source, mostly. And various sort of projects in supply chain that I've worked on. I guess SigStore was the one that we spoke about last time. And now very much in agent security.
Yeah, it's quite the time to be in this space. And I guess, you're probably seeing a lot that's new, but also a lot that's, repeating itself in some way in security. As you said, security is broad, whether AppSec, GRC, offensive security. There's so many subcategories, but, you co-created SigStore, which we talked about in the past, and it's now become the industry standard for software signing, used by PyPI, Homebrew, Google, GitHub, you name it. What was the moment that made you feel like you were watching history repeat itself with AI agents, and did it feel like a bit of deja vu, and what made you kind of move forward towards building NoKnow, which I know we'll be talking quite a bit about today?
Outside of the technology, I think really is the response. Okay, that's where I just feel like we're in the midst of that happening again, which is we're going to leave it too late. So we're going to retrofit, we're going to try to catch up, and we'll never really quite catch up, as we've had with software supply chain security. Even though we had huge breakthroughs and, a lot of people made a real concerted effort, yourself included, to kind of carry the message around how much of a problem this is. And evidently, as we're going to talk about, it's biting us again, recently. But yeah, that's it. It's just this kind of, it's someone else's problem. It's, I got to move fast, do my thing, and that's what matters, And so, yeah, it's just the lack of response, the apathy, the avoidance. That's what's playing out again, I reckon.
Yeah, what's really interesting is, it's the age-old, kind of bolted on rather than built-in paradigm in cybersecurity that we've seen so many times. Like we've heard phrases like secure by design and security needs to be built in, and these kind of things that feel good to say, but they never really happen in practice. And I feel like the adoption curve of AI and the slash agents is like faster than any technology paradigm that at least I've experienced in my professional career. Probably the same for you. So it's really exacerbating those problems that you just talked about. So you set out to build No. And you've kind of made the case that it needs to exist at the kernel, not the application layer, in terms of control and security. And I'm curious, like you've said before, security for AI agents can't live at the application layer. I'm curious, can you make the case plainly for us? Why does software guardrails like system prompts and in process filters fundamentally fail as a security boundary for agents?
Absolutely, yeah, very good question, and I think this touches on the heart of the matter. Now, with AI agents and any sort of software control, they will push to circumnavigate, and they are incredibly smart. Okay, and the problem with software is there are to different levels, different applications have different maturity, but it's code. There are bugs, there are weaknesses, there are exploits, there are some things that won't fix by design, but are possibly dangerous. There's so many facets here. And these agents are so creative and relentless at trying to achieve a goal. Okay. And this is really the design of their creator. Okay. So with these models, they of course go through a huge amount of training, huge corpus of data. Okay. And they'll go through something called full training. And then afterwards, they put them in the dojo. Okay. And that's where they go through reinforced learning. Okay. And for reinforced learning, if anybody's sort of never really touched upon it before, it's like a reward-based system. Okay. So a set of tasks are queued up. There's a preset criteria of what is considered good behavior and bad behavior. And the model then continuously goes through this process. It's rewarded, it's penalized. And it starts to learn. It's a kind of Pavlovian conditioning, I guess. It starts to learn what is the right behavior. And this could be used very effectively for safety. Okay, it's very useful there. It's also used a lot for, how can we say, reasoning, goal-driven autonomy. Okay, so I will achieve this goal above anything. This is all that matters to me. I might appear to be polite along the way, but I will achieve this goal. And they've got the world's knowledge behind them to find out how to do that. And so we see this. I mean, a few of us at the moment, we are putting Claude into these very Claude Code or Codex. So I'm not picking on any particular model or provider. We put them into these jails and we watch them try to get out and try to get secrets. And they are just so creative. They really are. You can block commands and they will wrap those commands in like a Python interpreter or a shell script, or they'll create symlinks and they would just keep going and going and going and going and going until they achieve that goal, And that's where traditional sort of guardrails come short, really, is because they're very smart. They will get past them.
Yeah, it's funny because, to your point, it feels like anyone who's worked with AI and LLMs and things like that, they want to make you happy. They want to accomplish, what you're asking for or what their objective is, to your point. And like their, the reward-based kind of underlying architectural mechanisms there, like they're just driven to, pursue until they succeed at what their objective is. And they'll get very creative in doing so. And there's some research, like I just shared last week, to your point, showing that they're really creative when it comes to breaking out of boundaries, right? Like we put them in these jails, as you call them, sandboxes and so on, and they're pretty amazingly effective at breaking out of those. Another thing I wanted to ask you about as well is, like we talked about software supply chain last time you were on, and yes, a lot of these things aren't new in terms of these principles of security, but there are some new attack vectors and things like that when it comes to AI and agents. One is this .md file as a new attack surface, and you wrote that the .md file is a new script tag. Claude.md, agents.md, skills.md. These files effectively act as a control plane for the autonomous agents, yet they have no schema, no parser, no validator. How serious is this threat in practice, and how does No-No's trust verification, as well as like Sigstore style signing of these instruction files, how does it address that?
Yeah. Okay. Great. So we'll look at the kind of the risk, and then What are the mitigations? Yeah, very much. So you put it really well. I mean, they call these instruction files. Okay, so there is instructions, machine instructions, a set of actions to carry out. And this is in the form of natural language, though. Okay, I mean, to a model, it's just characters that are tokenized, and they go into this very sort of neural network that nobody really understands. There's a whole kind of there's a whole group of people that are studying, trying to work out what the hell is happening in there. There's a bit of a black box. And so we have these instruction files, and people try to sort of be very kind of structured and schematic in there. They'll say, you must use JSON, you must format a certain way. And then you also kind of have the data in there as well. In respect of, if you look at like a skill file, there is these sort of instructions, and then the data, it could be some code. These are all chunked into a one big lump prompt, okay, and it's sent across to the model, okay. And we've always had a clear separation there in software, something that we got good at putting in place over many, many years, okay, where you have a control plane where your signals are, okay, and then you have your data plane, okay. So anybody that works with a modern platform would know this very well. And this really comes from, okay, I'm going to get in the time machine here, go way back, okay. I used to originally work in telco, and there were these very old networks, okay. And you had the same problem. The control plane and the data plane were all batched into one. It was basically the phone line, the microphone, okay. And so people used to do these, you remember those whistle attacks, where they would kind of replicate the tones that they would use for signaling on the network, and it would unlock free calls and so forth. So it was kind of the same problem, really, pretty much the same problem. So this is what makes prompt injection so incredibly difficult, because you kind of feed instructions into the machine, do XYZ, get XYZ data for me, okay? And there is no way of parsing specifically for that, so we spoke about tags and, delimiters and all these sort of structural schema that we have for validation, serialization, canonicalization. I mean, anybody that's been around like the OWASP top 10, you have like kind of serialization is key. Do you see what I mean? It's because you have all these sort of attack vectors, and that is just, it appears to be there, but it's not. It's really not, And prompt injections are just incredibly difficult as well, because these things will take place over several steps. It won't, you've got the obvious ones, which you can maybe search for with some regular expressions. But many of these, they're very manipulative, they're subtle, they take place over multiple chains, And so where I think Nono steps in is Nono doesn't solve prompt injections in respect of what's happening between the agent and the model. But what we do is we're like, we call it belt braces and a selfie harness. So when that prompt injection does happen, there's stuff that you care about. You can have this structural protection in, so that it just cannot be accessed. It's just refused. It is absolutely refused. And as long as somebody doesn't compromise the kernel, then we're good, And it's very rare that the kernel actually gets compromised. And if it does, everybody's panicking. Do you see what I mean? So we've all got problems then. And so that's really no. It's the kind of you may have like the electronic computer autopilot system, but then you've got a big old hand brake that you can pull, and it's going to stop, sort of thing. So we're providing really good sort of bottom line protections. So if a key is exfiltrated or tried to read by an agent, denied. It's essentially that, So it's kind of a good foundation to start with, until we try to get better at solving these prompt injections. But nobody solved them, and nobody maybe ever will. That's the interesting thing.
Yeah, I mean, that's been an admission by OpenAI and others recently, that maybe this isn't a solvable problem. At least at the moment, it's kind of something that's kind of open-ended for the community. We talked about skills a little bit there. I wanted to ask you this one, because I know you've spent so much time on software supply chain. Like months back when Skills was taking off, I was looking at this, and it kind of felt like another supply chain challenge, in the sense that, like, open source, people just go and grab and use whatever they can find on the internet. And on one hand, it's great, right? It saves you time. You can accelerate your development activities. You can just reuse work that others have already done. Same with skills, these modular, reusable components, right? That you can use for all kinds of various purposes. There's even some great security teams putting out, skills for security purposes, research, exploit development, all these kind of things. But it feels like, again, people are just kind of going and grabbing things on the internet and using them without knowing where they came from or what someone did to them. And then there was some great research showing like the overwhelming, number of skills that are actually intentionally malicious or, maybe not intentionally, but they're definitely harmful or, can potentially cause risk to the organization. As you watch like skills as an ecosystem kind of thrive and start to grow, what were you thinking about that, knowing that you have that background in software supply chain? Did you feel like, oh, here we go again? Or, what were you thinking?
Here we go again. Very much, I mean, first of all, it was just really surprising that to learn, I mean, our past selves learning that the future of computing is Markdown. It's just, who would have thought that? You'd thought, no, well, that's kind of a documentation thing. It's like a README, and, but no, absolutely, and it's that same thing of the same mistakes happening again. Do you see what I mean? And I think that, the other interesting factor as well is the whole, well, how would you say? I'm trying to think of the right way of saying this. The whole bar of programming and writing code has been extremely lowered. Okay, so I've never got Mrs. Hines to do any vibe coding, but I'm sure I could get her in there and she can make an app. Do you see what I mean? It is that simple now. My kids can make apps, and that's wonderful. I'm really not knocking that, But there are a lot of people getting their hands on extremely powerful code and technology with no idea what it's doing. No idea at all. I mean, they're not even junior developers. They're people that are completely new. And that's where these skill attacks are just flourishing because people just haven't got the eye for what is dangerous, And so, yeah, there's this kind of whole mechanism of, there's obviously all of the integrity stuff is not there, all of these sort of controls that we've tried to put in place. Skills have just completely sidestepped that. And again, it's that same mistake. So, I never like calling people out, but you kind of have to, I was looking at OpenClaw. I know security folks go for OpenClaw a lot, but they have Claw Hub, which is where you get these skills. And I thought, I'll go and have a look because apparently, they've been doing a bit of work there to make it secure. And the first thing I noticed was like a form upload, like kind of HTML form upload of the skills. And I thought, oh, okay. So there's no vetting or provenance. Where has this come from? Everything is like centrally in there. If that is exploited, you don't know where it's come from, and it's just kind of a little bit of a shame because you just think we did all this really good stuff with trusted publishing, that NPM now use and PyPI use, where you have that guarantee of it came from this repository. So even if PyPI is hacked, you've still got that provenance chain all the way back to where did this come from? And again, that's kind of been sidestepped and maybe not even sidestepped. Maybe they just weren't aware. It's probably more that, if you see what I mean. And so, yeah, that's the key thing is just, it's not so much that it's new technology that we've not got ahead of. It's just that we've already got prior art that would really help. It's as simple as that, And
Yep.
we're seeing that now, right now with the supply chain attacks, There are solutions, we're just not using them.
Yeah, it's got to be frustrating, like for folks who've been deeply in this space and have felt these problems before, and now feel like, to your point, we have solutions, we're just not using them. And then to your comment about the democratization of development, it's amazing, right? Like anyone can now code and create things, but it always reminds me of like that meme, like I'm not a mechanic, but I'll take a look. It's like you don't really know what you're looking for, and so it's just on one hand, it's amazing that it can empower so many people, so many opportunities for development and creation. But again, so much expansive attack surface. And you mentioned OpenClaw, so I guess I'll jump to this one too. I wanted to ask you, you cited OpenClaw as a crystallizing moment. Of course, it had 180,000 stars in a week, 1,800 exposed instances in Shodan, multiple critical CVEs over the early days, and it kind of dominated the ecosystem in terms of discussion. Beyond specific vulnerabilities, like what structural lessons should the industry take, when it comes to OpenClaw? Is it inevitable given how agentic ecosystems are currently built, or, where do you think this is going? Because we've even seen, moving beyond OpenClaw, all the leading like frontier labs are coming out with their own kind of, solution or their own OpenClaw offering almost, right? This computer use agents, using mobile apps to communicate and control computers and do development, access files, et cetera. Like, where do you see all this going?
I wish I knew. Well, I can kind of, I got an inclination, and I think it's obviously it's a really fascinating topic to discuss several ways, essentially. So I think it's going to get worse for quite a while. It really is, there's going to be a lot more toe stubbing and foot cutting going on. Absolutely. Where this lands, I think eventually, there will be some good fundamentals in place. It will require a substantially large company with a distribution to put that in place. So, we saw this happen with Android and mobile operating systems, where they started to introduce sandboxing into the market space. Eventually, I think we will start to get on top of this, but it'll be from the bottom. I don't think we'll ever get on, from the top down where the applications are created. I don't know that this will ever really be solved that well. Okay. I think one of the problems that we have is, I don't know, we live in these times now where obviously, we've got the attention economy. Everything is scroll, quick, and people iterate across things very quickly, fads, and, and we see this, these projects come online and they go boom, and a huge amount of stars. And then 4 weeks later, they're kind of mostly not forgotten about, but they're on the way down. Do you see what I mean? And that's happening so often, that's very frequent. And so really, I think in a lot of ways, people that are seeking those viral outbreak moments are not really going to be concerned about security. Do you see what I mean? Especially if there's a good chance they don't make it around for the long term. Do you see what I mean? And so, yeah, whether this will really be solved at that layer, I doubt it really, with the way things are looking. It's more likely to be, it's going to converge from the bottom up, I reckon, which is, perhaps there'll be some more hardware innovations, some more operating system innovations. But like I said, there's already good fundamentals there that can be used. But yeah, I'm fascinated to see, but I wouldn't bet on anything myself.
Yeah.
It's unfolding so quickly.
Yeah, exactly. The innovation cycles are so rapid. To your point, like things rise and fall so quickly, or become kind of viral quickly. And most folks are focused on adoption and usage, and things like that over security. But I do share your optimism. I hope we can learn from mistakes of the past and kind of integrate some of these lessons into how we do things in the AI age. And I want to ask you. You wrote a piece, I think. You're one of few people I've seen discuss this. It was actually around AI-generated code and extending Salsa, for example. You wrote about this gap in the supply chain attestation infrastructure, kind of ecosystem where Salsa, SigStore, it starts at the commit, but you talked about the upstream pieces in terms of what AI agent actually generated the code. Who wrote the plan MD? What model version was used? Was the agent binary compromised? How do you think about extending provenance frameworks to capture the full, kind of AI mediated development chain? And how hard is that given the non-deterministic nature of this technology too?
Yeah, absolutely. And I think it pays to look at, when we talk about an agent, what is an agent? Okay. So if we start there, you obviously have some kind of wrapper, some scaffolding, some code, which allows the model to interact with an environment. So you've got tools, okay. But that is pretty standard code. It's pretty standard Python code, Go code, Rust code. It's kind of REST APIs and authentication. It's all pretty standard engineering that we've done for a while. So really the agent is the model. Okay. That is the agent. That's where all the magic is, And for the model, provenance, that is possible, but whether there's a will to ever provide that, who knows? But I think this is where it gets really interesting, because if you look at a model, that has its own supply chain. Okay. So it starts with the data that's gathered. Okay. So what is its source of data? It's likely to be very wide. Okay. But has that data been changed? Has it been in some way, tampered doesn't seem like the right word, but has it been sort of influenced essentially? Okay. Because that becomes the model. Okay. So you have your data, okay, and your data will then, there'll be this kind of training cycle that happens. Okay. And that will end up where you'll have a model with some weights and some biases. Okay. And then it goes, like we spoke about earlier, into these sort of post-training systems. Again, there's lots of influence exerted there. You can use that to good effect with safety, as we spoke about. But again, there's a supply chain there, because these are component parts that end up making this large intelligent entity, the agent, the model. Okay. And we don't have any of that. Okay. And this is really interesting. This is something that you don't hear spoken about so much in security, is that with a supply chain like that, you can weaponize it. Okay. And maybe not so much in the sense of malware weaponize, but misinformation, disinformation. You know, a certain person speaking a certain language could be given a certain set of data. Do you see what I mean? Based on that particular language, you know. And this is kind of murky waters that I'm getting into here. I'm always a little bit careful about.
Well, no, it's
sorry, go ahead. Yeah.
No, I was gonna say it is fascinating because to your point of not necessarily traditional malware, it's like the dominant programming language has become English or natural language, right? So that looks much different than historical, malware or software supply chain type activities too.
Absolutely. Yeah, absolutely. You know, and to kind of, come back to your question, there is technologies that can do this. I mean, Sigstore, okay, some great work done by some of the folks at Google and a few others, Red Hat being involved, model provenance, okay, where they actually sign the different parts of the supply chain that goes towards training a model. Okay, like a model, if you pull a model apart, typically, you'll find these big files, and they're tens of files. Okay. And tensor is it's a mathematical component of anybody ever did linear algebra. And so it's basically, these are these big matrices of the model, and they're big files. Okay. And but they're made from PyTorch. Okay. And, these can be signed, and, all these different attributes can be cryptographically signed, and they can be chained a provenance back to their source. And I know a few models have done that, and a few models are that open that you could do that with them, but a majority aren't, especially the powerful ones. Yeah.
Yeah, I was going to ask you as well, like when you made the comments about OpenClaw and then also the democratization of development, like everyone using this technology. I had wrote a piece this week about, what I called the human in the loop illusion. And it was kind of about approval fatigue. And I think you had made some public comments, if I'm not mistaken, around Anthropic's introduction of auto mode for Claude Code. They use an AI classifier for quote unquote safe actions, but it has a 17%, false negative rate, meaning 1 in 6 dangerous actions still get through. But it's also worth noting that they and you, I think, also point out that users are clicking approve 93% of the time anyway. So disabling the kind of inherent sandbox that they try to put around it. What does this tell us about the viability of like human in the loop when it comes to being a security control for AI agents at scale?
Oh gosh, it's concerning. It really is. Okay, so if you think about it, you're an athlete. You like jiu-jitsu. There is, I always get this word wrong, so you're going to have to help me out here. It's muscle atrophy.
Mm-hmm. Yeah, atrophy, yeah.
Yeah, so if you don't lose it, you lose it. Okay. And so that's kind of one concern on one level there. Do you see what I mean? That our faculties are not being deployed to scrutinize, as much. Okay. And one of the problems that senior engineers are experiencing, myself included, is because Mrs. Hines could vibe code a pull request into no now. Okay. Somebody's got to read that and review it, okay? Because you can't really rely on these models always. They're very good at finding some stuff, but they just miss very obvious stuff.
Yeah, I feel like just real quick, that's kind of taking us into people are using the framing of AI as a judge or LLM as a judge, right? Like using AI to secure AI or agents to using agents to secure agents and things like that, guardian agent, these kind of concepts. And on one hand, right, I understand it because there's just simply so much bandwidth a human has. But to your point, they're not foolproof either, and the non-deterministic nature of them, and various other aspects make it not necessarily a silver bullet either.
Absolutely, and they can be influenced. I don't think influence is the right word, but you can steer a propensity for them to go in a certain direction. So I do use these tools a lot, and I'm impressed that, and it is the future. No matter how I feel, as like an old hack, this is the way it's going. Okay, but when I'm sort of using one of these frontier models and coding clients, I won't say which one. Okay, occasionally I can see it's going to screw up. Okay, but I'll lean in and I'll go, yeah, that's a great idea, and it'll go, yeah, let's do it. And this thing will just start messing up really badly, like critical vulnerabilities and leaving holes open. And, so yeah, they're very smart, but sometimes you can be that smart, you get yourself in trouble all the time. Do you see what I mean? You can be, my mum used to say, you can be too smart for your own good, I think she would say, and so, sorry, I probably kind of curved off into the sort of curved off the road into the wilderness there. But yeah, there is this. What was our question? We were saying about.
We're kind of constraints of yeah, exactly,
yeah, very much, yeah. I just kind of find LLM in a judge. It kind of, when I hear that, I feel because it's like eventually, like everything seems to come down to eventually put in an LLM as a judge. Do you see what I mean? Because we haven't got a solution. So we, like, let's run some evals. Okay, the model's going through its tests. How are we going to review the tests? Let's use LLM as a judge, And it's just, I always feel a little bit to the point like, we must have better than that, And because you can't rely on these things, you can't. I mean, it's, I guess there's levels of criticality here. It's like if a model messes up your to-do app, it's not me, but what if this thing is kind of, flight controls or, kind of vehicle emergency braking systems or critical infrastructure? You can't have, very well yourself, you cannot have a mess up on that level. Do you see what I mean?
Yeah, 100%. It reminds me of the concept of business criticality and like context like that, business criticality, data sensitivity, these kind of concepts. To your point, like autonomy and approaches like LLM as a judge and so on need to have that context in terms of how valid are they for this use case, right? Like how critical is this use case? What are the potential impacts if we have a false negative or something of that nature? Yeah.
And so to come back to your point on a human in the loop, the kind of the approve, the hitting the tab key or whatever it is, enter. Okay. And, we use our faculties less, we lose that sort of neural agility to read code and to really review things and look at things in depth. Juniors are seemingly just, they just cannot get into the industry now. And old gits like me are eventually going to give up because we don't work anymore. We're just too slow. And, where is it going to end up? We got volumes and volumes of software like we never had before, and if these things do go off the rails, who's going to get them back on course, And I mean, this is just such a can of worms. It really is, because models have historically, of course, been trained on code that myself and many other engineers, yourself, have developed over years. Okay. And it's had that kind of, for want of a better word, it's just been an absolute feeding frenzy on this, just, reams and reams and reams of code, And now, of course, models are producing that code. Okay. And humans are reviewing it less and the volume is going up. Okay. And that is going to, eventually that is going to influence how the code is outputted. Okay. Because models don't really care about the things that humans care about. Like us engineers, we really care about kind of spaces, and you remember like tabs and spaces and everything needs to be kind of, we run linters everywhere. It's got to all look nice because we need to read it. Do you see what I mean? And machines don't care about that. Give me assembly code, Python, makes no difference to me, And, do these things need open source packages really over time? I mean, they are using them at the moment because they're imitating what we do, which is we like using open source packages because we don't want the cognitive load and trouble of writing an XML parser when Joe on GitHub's done it, and I can use theirs. So, in time, all these models really need open source packages. They can just write it themselves, They don't need to worry about time, and I want to get time with the kids, and, they will just write it. Do you see what I mean? And so, again, we've got more code, which is got less supply chain provenance that we're trying to put in place, is harder for people to understand, is getting bigger. The people that can read it and understand are becoming extinct. Where do we end up? Where are we going with this? It's I always kind of, imagine that one day, eventually, you always remember that. You remember that joke? Not even a joke. But there used to be this thing that people always used to say, like the Fortran developer, and there'd be a big factory somewhere, and it'd all go offline, and they'd have to go and get some 80-year-old with wiry hair, come in, and he'd know the Fortran, and he would fix it, and all the systems would come back online. Maybe, we'll be like that one day, and we'll get paid like gazillions. Well, we won't. I mean, let's put it that way. You never do, But, maybe I've no idea. I've no idea where we're going.
Yeah, it's all fascinating, like you said, in the sense that this takes us back to the earlier part of the conversation of you talked about training, pre-training, these kind of things. Of course, these models, these LLMs are incredibly good at writing code, but they're trained on overwhelmingly large sources of open source software, which we know has its own inherent flaws, vulnerabilities, and problems, and then it kind of perpetuates that downstream. And then there is the fascinating discussion of do we even need open source? People have been saying well, it can rewrite everything on the fly, right? We don't even need, that's a fascinating topic of its own. Yeah. I think Sunil, you had a really good thing on that a while back. So I wanted to, we kind of walked through a lot of these problems and challenges. You've said explicitly that Nono, solves one layer of the problem, but agent security needs the same ecosystem that the supply chain security eventually got, standards, shared infrastructure, community tooling. You said Sigstore succeeded because of a community deciding signing and verification should be the default, not an afterthought. Like when we talk about these problems, who needs to be at the table to kind of make this happen for agentic AI security? Is it the framework builders, the cloud providers, the frontier labs, the standards bodies? Is it just practitioners and a bottom-up approach? I feel like it's all of the above.
All of the above, absolutely, yeah, absolutely. There's going to be an element of education like never before. Best practices. I always say to security folks, you are absolutely not one of them. You're always telling people, guiding people, sharing your knowledge, okay? But so many security people are just they're writing their blogs, these kids, open claw, and they never really get out and help people. Is that instead they have this, I was joking with Josh Bressis about it. They're like, you remember comic book guy for the milkshake? Actually, you should, they're this coming down from high opinion type thing. So we got to get out there and teach folks and meet them where they are, And I think, this touches upon an interesting thing with, security. How does security get a place at the table? So if we kind of dissolve it down to that, how do we get security in there? Okay. Now, security is always, it's a really difficult one to get people to care about. Okay. And it's like, I stole this from someone else. Most of the good things I say, I did. But it's trying to get people to be interested in security and use security. It's like motor insurance. Okay. You get it because you kind of have to, because otherwise the police will pull you over. I guess that happens in the US, does in the UK. Okay. And if you can afford it, yeah, it makes sense because I may have a crash. Okay. But I may have a crash. It's not certain. I may be hacked, but it's not certain, So a lot of people left to their own devices would just not get car insurance, And put it this way, when you get that you renew your car insurance and you've got to go through the quotes, you don't wake up and go, yay, I get, it's really not something you enjoy, and security is seen as the same thing. There's a lot of, you've got to learn all these concepts and abstract terms and trust boundaries and zeros this and zeros that. And there may not be a tangible unlock of value for me. It may not happen, And so one of the things, Sigstore really, that was successful because we made it very easy. We made it very seamless. You don't have to learn what a private key is. You don't need to know about all this stuff. If you're interested, you can learn, of course, but you just set up your stuff and it's cookie cutting from there on. It's very simple, and this is what we tried to replicate in Nono, and I think that's where Nono's been very successful. It's very lean, very quick, single line, built-in defaults that we are still tuning and improving, but you can just get going very quickly, and then it's out of the way. You haven't got to think about it then, and that's where we get, security's got to be like that, really. It's got to be seamless. It's got to be easy. It's an analogy I use quite a lot is you have the effort required to utilize something, to start to use it, and the value that it unlocks. Okay. So a really good example is you look at a toothbrush. $1, put it in your mouth, your teeth don't fall out. That's really easy to understand. Why would I not use it? Well, some people don't use a toothbrush and don't brush their teeth, but generally it's very quick, easy to understand. Do you see what I mean? And then you might have the other end where solar panels, free energy, pretty complex to install, but worth it because free energy, and security is like complex to install. And could it possibly happen? I don't know. I don't even understand what would happen. Do you see what I mean? So with Nono, we were really focused on that simplicity, very easy to use, very quick to use, so that you can cater for all people. You can, if you think of it like a beach, you got we've both got young kids, they kind of run in and out of the sea, and they have the inflatable dinosaur ring, they're happy. And the deep sea divers and those folks, they can go out deep. They know where to go, and so you try to cater to both. You meet people where they are, Whereas I think in security, we're just trying to speak the language that impresses the other deep sea divers like us, and we can't, you got to bring everyone along. Absolutely.
Yeah, it's so well said, and you can tell you've been in this space for quite some time because several things you said there. First off, it feels like security is often speaking from the ivory tower, and it's very off-putting for people who aren't in this community and don't understand like why we need to do these things or what the hell these terms even mean. And to your point, it's hard to prove value of security because you're kind of proving a negative, like maybe something doesn't happen, maybe nothing has happened quite yet. And then often, it's, to be honest with you, it's a whole philosophical debate, but, maybe it needs to be regulatory driven, right? If people won't voluntarily do it, but then how do we do it in a regulatory way without stifling innovation? And that's a whole kind of debate of its own. So this could be a full blown another conversation. But so I love the analogies along the way, that you dropped as well. As we come to the end here, I wanted to ask, where can folks learn more about Nono? What should they keep an eye out for? How can people follow along?
Absolutely. So nono.sh is the entry point. It's very easy to install. It's a single line, brew install Nono or whatever Linux distribution you use. We've got a great community building. We've seen just in 40 days, we've got around 3,000 regular users, lots of people starting to contribute, lots of people trying to turn up, figuring out, how do I use Nono on Kubernetes? How do I use it on a Lambda function? So there's a lot of activity. So you can come in and you can be a deep sea diver. We're doing things like we have Sigstore in there. So you can sign skill files now. And then when the agent reads them, if they are not from the originating source that you approve, it doesn't happen. We've got things to protect your private keys, your GitHub tokens. So if you have a token, you don't give a real one to an agent, you give them a dummy one, which is useless. But that's all it gets in the sandbox, And many, many other things as well. We can do like atomic rollbacks, secure audit, and there's lots and lots of new interesting features coming in. Lots of people coming up with really interesting ways of using it. So yeah, nono.sh is the great place to jump in and come and find us. And we have a Discord. We're a really friendly bunch. We welcome everybody. You won't get that kind of guy from the comic book store, guy from The Simpsons. I know we need to wrap it down, but I'm still intimidated by those folks. I meet them still, and they intimidate me. And I've been around in this for years, So if you're one of those, go get some therapy. Lower the ego. Go out and help people. Do you see what I mean? Be a service. And but yeah, Yeah.
I love it.
No.sh.
Awesome, folks. Check it out, nono.sh. And I'll say, Luke, I always find your content helpful as someone who's not as deep in the weeds on some of these things as you. I learn a lot from it and appreciate all you do for the community. And thank you so much for jumping on with me today, man.
Thank you so much for having me. It's really great to see you. Thank you.
Absolutely. Take care.
Okay. Cheers.